Okay, class 7, this lesson 1.5, digital text and numbers. In this lesson, you will learn how numbers are stored as a digital data, how text is stored as a digital data, what is a value. I want you to focus, okay, and follow with me carefully so as we are going to identify what do we mean by a value. Okay, what do we mean by a value? You use numbers every day. Some of those numbers are used in calculations. For example, you add or multiply the numbers together. In this type of number is called a value. That means what? When you get a result of multiplication or a result of additional or result of division, result of subtract, that means we will say this number is a value. Okay, but for example, if I ask you what is your age and you said my age is, let us say, 13, or you said 14, that's not a value. Why it's not a value? Because it is not a result of any type of calculation. Okay, for example, if I said for you, let us say, how many members, okay, how many members at your how many members at your home, you will say 5 6 like this. So there is no it's not what we will say, it's not an number, or it's not a result from the calculation, so it's not a value. Okay, other numbers are not values. See, focus over here. A phone number, it's not a value. You don't add phone numbers together or subtract phone numbers from another. When those two types of number are sorted as a digital data, they are stored in different ways. Okay, as I said for you, because I'm gonna ask you to do this activity. Okay, your house number, the number of marks you got in a test, means in computer exam. Your age, we already solved this one. Look here, we said age, it's not a value. Age, it's not a value. Okay, the number of points your team scores in a basketball game. Okay, so you are going to do this activity. Okay, as we said over here, okay, we talked about we talked about the numbers, okay, and how numbers saved on the computer. So what about the rest of the things on the computer? Or type, other types of content, like what? Numbers values are sorted inside the computer using the binary number system. We said before, and we all agree, all the things stored or saved on the computer will be as a binary number system. There is nothing will be saved on the computer as a text or letter or something like that. But what about other types of content? For example, we are using the computer every day. So that means what? We are using numbers, text, pictures, sound as well, right? So all of those types of content must be turned into numbers. That means computer will generate them into numbers, not any other number binary system. Then the computer can store those numbers using the binary number system. In the rest of this unit, we are going to speak, or we are going to explain, okay, how computer stores text, images, and sound as a value number. Okay, move to page number 13. Page number 13, sorting text using ASCII code. ASCII code. Okay, ASCII code, it's we spoke before when we introduced the binary system. We spoke about the ASCII code. It's a American standard code for information interchange. Text characters including letters of the alphabet, punctuation, marks, and other characters that you can type on standard keyboards such as space and math symbols. That means what? On the keyboard, look at the keyboard in front of you. We spoke about the letters, right? We spoke about the letters, and also we are having numbers on the keyboard, and we are having symbols, right? Like add, okay, hash, and also star, and we are having also two brackets, okay, and there is plus, equal, all of those symbols, all of those numbers and letters, okay, they are having special okay way or special method to be saved on the computer. Even though the space, okay, look here, even though the space, it has also a way to store on the computer. That means everything fix it well, okay, on the computer, and how to be saved on the computer. The computer uses a number code to represent those text characters. There is a common code used by almost all computers. It's called ASCII code. Okay, this is a shortcut for the long sentences. American Standard Code for information interchange. We will just say it in short form, ASCII code. Here are number codes for the letters A to J in lowercase. Different codes are used for uppercase. So pay attention. Okay, look here. We are having the lower case. Okay, the lower case means what? Small letters. Look here. Okay, means while we are writing, okay, the numbers we are having, okay, we are having here what? We are having the small letter, and also we are having here the upper letter, right? It's mix it up, no problem. Okay, so we are having the upper, and we are having also the lower letters, capital and small, and they are having different kinds of numbers. For example, we are having from here from A to J. Okay, A number code is 97. You have to save it. See, it's going in sequence: 97, 98, 99, 100, 101, 102, 103, from A to G. Okay, ABC up to G. Only small. We are talking about the lowercase, not the uppercase. How the computer uses ASCII code. When you press a key on the keyboard, look carefully, it sends a signals to the processor. So we are speaking right now about the method, okay, the functioning of uh, saving the letter. When you press a key on keyboard, it sends signals to the processor. That means whatever key you are pressing on the keyboard, whether 1, 2, A, B, C, space, any kind of punctual letters, punctual symbols, okay, like that. The uh, the signals, okay, varies according to which character you selected on the keyboard. That means it the computer will identify which kind of character you pressed on the, or which kind of button you pressed on the keyboard, and after that the computer will identify that character, and according to that character will be saved to equivalent number of that character. When the processor receives the signals, it stores the character using ASCII code. It stores the binary number. So for example, okay, this is good. The letter A, it's stored as the binary number 0, 11, okay, 0000 1. The character B is stored as a binary number 0 11 and 00010 and so on. How we got those numbers? Someone can ask me, teacher, you said the character A, the equivalent number or the equivalent code number is 97. So you are going to change, okay, uh, you are going to convert, to be exact, you are going to convert 97 into binary number because 97 is a decimal number, right? 97 is a decimal number, and computer will not save the information as a decimal number, only binary number. So you need to transfer those binary numbers into those decimal numbers into binary numbers. Okay, move to page number 20, page number 24, page number 24. I'm going to complete the explanation. Sorting other characters. As I said before, everything on the keyboard has a numbers, okay, has a numbers on ASCII code. You have used ASCII code to represent lower cases letters from A to Z, okay. We took from A to J, and after that you can continue. How? Okay, here we said A97, and every time we are adding 111. So continue from J up to Z, adding 111. So you will get the full alphabetic letters and the equivalent code number. Okay, like for example, the next one will be 120, 104, and after that 105, 106, and so on. Okay, up to Z. Now we finished from the letters, okay, the alphabet letters. Now we are going to speak about the symbols, okay. Symbols, as I said for you, as space, comma, and full stop. Example, okay, space 32, comma 44, and full stop is 46. Okay, those are examples of symbols on the keyboard. Okay, moreover, this is very important also here, a number in ASCII code. This is very important, a numbers on the ASCII code. And there is difference over here, there is big difference. When we are speaking about numbers, we are speaking about the numbers on the keyboards, okay, not the value. Look at your keyboard, you are having numbers from 0, right, 0 1 2 up to 9. Okay, so all of them, all of those numbers, okay, has individual ASCII code in decimal. For example, 0 will be 48, and 1 will be 49, and 2 50, and 3 51, and so on. Same like the letters started from 97, the letters from 97, and the numbers, okay, and the numbers, they are started from 48, 48 and 49, 50, 51, and so on until you reach the number 9. Okay, so the computer can store a number using ASCII code or as a number value. Different number value means what? It's the result of calculation, any calculation, so that will be a number value. But when you press a single number from here, it will represent only a number, okay, or character number from 0 up to 9. Different types of software stores numbers in different way. If you type the number 93 into a word process document, the computer will store ASCII code for 3 and 9. Okay, look here carefully, this good explanation. Now if you are typing anything on the word program, okay, and you press 93 39. So the computer will store, okay, the value of 3. What is the value of 3? It's 51. Okay, and the value of 9 will be, this will be 52, 53, 54, 55, 56, 57. So the computer will save 51 and 57, okay, as a representative of 39, because it's a combination of two numbers. You cannot do a calculation using a word processor. Okay, a word process, we cannot do a calculation while we are using the word program. But if you type the number 93 into a spreadsheet, which it means Excel program, the computer will store the number value 939. You can do calculation using spreadsheet. So what is the difference over here? Word program, it's only a text program, so the computer will save the value of 3 and 9. But while using spreadsheet or Excel program, the computer will store 39 as the value number. Okay, so this all about today class, and we are going to continue next class inshallah.